Okay, lesson 5 of chapter 5. We're going to be talking about the Pythagorean Theorem. And with the Pythagorean Theorem, you are dealing with right triangles. A right triangle is a triangle that has a 90-degree angle in it, like this. Okay? The shorter sides of the right triangle are called the legs. Okay, so this is a leg, and this is a leg. The longest side of a right triangle is the hypotenuse. The hypotenuse is always opposite the right angle. Okay? Now, if we were to measure this triangle, which we're not going to do right now, I can tell you that BC is 6 centimeters. And CA is 8 centimeters. And there's an equation based on the Pythagorean theorem that states that the legs, which I'm going to call A and B, the sum of the square of the legs is equal to the square of the hypotenuse, which I'm going to call C. Okay? So if I square BC, which is A, 6 squared, plus 8 squared, I will get the length of the square of the hypotenuse. Okay? So 36 plus 64 equals C squared. 100 equals C squared. Now, if I take the square root of that, I'll get that C is equal to 10. Actually, when you take the square root of a number, it could be positive or negative, right? But obviously, you're not going to have a negative length here. Okay? So, having figured out C, we know now that AB is 10 centimeters. The square root of 100 could be positive or negative 10, but we know that the length of the side can't be a negative distance, can't be a negative length. All right, so this Pythagorean theorem you're going to use a lot in math, and you have to remember that the sum of the squares of the sides is equal to the square of the hypotenuse. Sometimes they'll give you the measure of the hypotenuse and one of the sides. So you're going to have to do some algebra to figure out what the other side is. Okay? And it's a right triangle. The other thing that you should remember is if you know all of the lengths of the triangle, of the hypotenuse and both the legs, you'll be able to tell if it is truly a right triangle by squaring and adding the legs. It should equal the square of the hypotenuse. Okay? So that's one way to prove it. Okay, in this example, it says to write an equation that you could use to find the length of the missing side of each right triangle. Then find the missing length, round to the nearest tenth. So here we have A squared plus B squared is equal to C squared. And we have plugged in 12 and 9 into the equation, the Pythagorean theorem. And then we get 184 plus 81 is equal to C squared, which is 225. And the square root of 225 is 15 or negative 15, but obviously C is going to be 15. So in this next example, example 2, they are giving you the hypotenuse and one of the sides. And they want to know what the other side is. So we're going to subtract 64 from both sides here. We're going to end up with 512. And then the square root of 512 is approximately 22.6. I prefer keeping the radicals. So if we do that, we've got radical 512. if we divide, half of 512 is 256. And then half of, right here I can see that 256 is 16 squared, right? So 16 times 16. So I could go ahead and pull out these pairs, and I could say instead of 22.6 and using a calculator, I could say it's 16 radical 2, because this 2 is going to stay in the radical because it doesn't have a pair. Okay? All right, in the example here on D, they ask you to determine whether each triangle with the sides given is a right triangle. For it to be a right triangle according to the theorem, the shorter sides squared need to equal the longest side squared. Okay? So if we look and see, those are pretty big numbers. I'm going to go ahead and just do E instead of doing D, because those are big numbers. So I'm going to take 4 squared plus 5 squared should equal 7 squared if it's a right triangle. Okay? So we've got 16 plus 25 equals 49. Is that true? I can already see it's not. So that is not a right triangle, because this is 41, right? 6 and 5 is 11. 41 is not equal to 49, so it is not a right triangle. Okay?